Russia's fifth-generation fighter, the Sukhoi Su-57, is a project heavily criticized by some Western analysts for allegedly having some weaknesses in relation to its stealth compared to other stealth fighters, which would leave it at a disadvantage against ultimate-generation fighters. Criticisms aside, the Su-57 has some very interesting features, several of which do not exist in Western fighters, which can partly compensate for its lesser stealth. So today we will look at 5 incredible facts about the Sukhoi Su-57. 1. Side radars. Virtually all fighter jets in the world today have a single radar located in their nose. This radar is responsible for covering the frontal sector, with a traditional coverage of approximately 60 degrees on each side for traditional active electronically scanned radars, or up to approximately 100 degrees on each side for radars with a repositioning system, such as that of the Gripen E and Eurofighter Typhoon. The Su-57, however, has a different philosophy. Like all fighters in the world, it has a main radar in its nose. It is a powerful ESA radar with more than 1,500 transmitter modules, making it certainly the most powerful radar ever installed on a Russian fighter. However, in addition to this main radar, the Su-57 also has 2 other radars installed on the sides of its front fuselage. These are ESA radars, which operate in the X-band, and which greatly expand the Su-57's arc of vision, allowing it to detect and guide missiles against targets approaching from the side, or even to guide a missile as it moves away from its target. This gives the Su-57 a much wider view of its surroundings compared to any Western fighter and expands engagement possibilities. Another advantage of this architecture is that these radars, both the side ones and the main radar, also function as high-power jammers for electronic warfare missions. However, by having more antennas arranged in different positions, this set allows for very comprehensive coverage of almost 360 degrees for its interference capacity, also far superior to its fifth-generation American rivals. 2. Low-frequency radars. In addition to the radars just mentioned, the Su-57 also has another set of radars installed on its wings. These are radars that operate in the L-band and their main function is to detect stealth aircraft. Since it is not possible to achieve the same level of stealth on all radar frequencies, stealth fighters are generally optimized to have the lowest RCS in the X-band, which is traditionally used in fire control radars and missile seekers. This stealth is degraded as the radar's operating frequency decreases, so that the RCS of a stealth fighter against L-band radars can be several times greater than the RCS of the same fighter against X-band radars. Thinking about taking advantage of this counter-stealth capability of low-frequency radars, Russian designers installed 2 L-band radars on the wings of the Sukhoi Su-57. It is unclear whether these radars can guide missiles, as the main disadvantage of low-frequency radars is lower accuracy compared to higher-frequency radars. However, considering the worst-case scenario, even if these L-band radars are not accurate enough to guide missiles, they can achieve early warning against stealth aircraft by directing the main X-band radar against opponents with all the power concentrated on a very narrow beam, which can even double the detection and tracking range of the main radar compared to the traditional mode of operation. In other words, the L-band radars in the wings allow the Su-57 to engage a stealth aircraft at up to twice the distance it could without these low-frequency radars. 3. Directional Infrared Countermeasure System. The Su-57 will be the world's first fighter to be equipped with a directional infrared countermeasure system. This system is very similar to the principle of operation of a jammer against a radar-guided missile, only made to interfere with heat-seeking missiles. It basically consists of a turret equipped with a high-power laser. Once the missile approach warning system detects an approaching enemy infrared-guided missile, the countermeasure system directional emits a laser in the direction of the missile's seeker, which has its receptors saturated by the energy received and loses the ability to see the target. In other words, the system is capable of blind an enemy missile. The Su-57 is equipped with two systems, one located in the dorsal column and the other below the forward fuselage, ensuring a good level of coverage. This system should guarantee superior protection to the Su-57 in short-range combat, where heat-seeking missiles are generally used, as well as in low-altitude flights, where portable missiles represent a serious threat to any fighter. 4. The Su-57 will be a wax killer. As mentioned previously, one of the biggest criticisms of the Su-57 is its level of stealth, considered inferior to Western fifth-generation fighters. Even if this is real, it is necessary to consider that the RCS of the Su-57 will still be dozens of times smaller than the RCS of the MiG-31 or any fighter derived from the Su-27 family, especially with these in combat configuration. Additionally, the Su-57 is being upgraded to internally carry the R-37M long-range missiles. This missile is designed for long-range aerial combat, with an estimated range of up to 400 kilometers against large targets. This means that in the worst-case scenario the Su-57 will be able to have the detection distance by an airborne early warning aircraft compared to the previous generation of Russian fighters. For example, a Western AWACS that can detect an Su-35 at 500 kilometers will detect the Su-57 less than 300 kilometers. While this is still a considerable distance, it is more than enough to launch an R-37M missile well within its lethal range. In a real conflict, this combination of a low RCS, even if not as low as an F-22 or F-35, plus a missile from range ultra-long, would pose a serious threat to airborne early warning aircraft, tanker aircraft, signals intelligence aircraft and any other large aircraft designed for mission specials. 5. There will be a high supercruise. Being able to fly at supersonic speeds brings a series of advantages in combat. Greater speed increases the range of weapons, reduces exposure time to the enemy and allows you to cover greater distances in less time. However, most fighters need to use afterburner to fly at supersonic speeds, which greatly increases fuel consumption, making it impractical to maintain this flight regime for prolonged periods. The ability to fly in supercruise partially solves this problem, as it allows supersonic flight without the need to use post-combustion. Fuel consumption in supercruise flight is still higher than in subsonic flight, but considerably lower than in supersonic flight with afterburner. The Su-57 units already operational in the Russian Air Force cannot yet fly satisfactorily in supercruise because they are equipped with interim Saturn AL-41 engines, derived from the Su-35 engine. However, the units that will be delivered from the year 2024 will leave the assembly line with the new, much more powerful Saturn AL-51 engines. These engines will allow the Su-57 to fly at speeds of up to Mach 1.6 without using afterburners, a capability very similar to that of the F-22 Raptor and which not even the MiG-31 has, since although it is faster, it still needs afterburners to reach high speeds. This should increase the lethality of the Su-57 in aerial combat. It will be able to launch its missiles against more distant targets and, in the event of a disadvantage, it will be able to disengage and escape if necessary. Observing these capabilities mentioned here, it is quite clear that much of the criticism of the Su-57 is unfounded. Its RCS may indeed not be the smallest of the fifth-generation fighters, but it is still much smaller than the RCS of the previous generation Russian fighters. Furthermore, he will bring a range of innovative capabilities globally. The best example of this is its set of sensors, made up of 6 radars spread across the fuselage covering different directions and frequencies and which should provide a very high level of situational awareness. At the moment, none other fighter in the world has a similar capability, with all current models having only a single radar on board. Another innovation is the directional infrared countermeasure system, with the Su-57 being the first fighter in the world to have a system like this. It is difficult to measure exactly how effective the Su-57 will be in combat, especially against other stealth fighters, but underestimating it is undoubtedly a big mistake. Thank you for watching the video. Don't forget to subscribe to the channel and see you next time.